In the given equation, k is an integer constant. If the equation has no real solution, what is the least possible value of k? Here are 3 ways to solve this problem. Number 1, you could break a single variable equation into a system of equations. The solution is the point of intersection, and then you would bump up or down 1 unit. So to reiterate, the point of intersection is basically exactly wrong because that's where they intersect, and you want them to not intersect. So I'm creating my system of equations. I do the left side of the equal sign, set it equal to y, and then the right side of the equal sign and set it equal to y. And now I'm just using my slider, sliding up and down, seeing where do they perfectly intersect. That's at k equals 49. And then I'm going to logically bump it up and down. I'm trying out 50. That's my answer. Notice that it does not hit the x-axis. And just out of curiosity, I plugged in 48 and I verified that 48 is not right because it actually does hit the x-axis at 2 points when you have k equals 48. Way number 2, you could rewrite in standard form and set equal to y. Use the slider for k. When k equals 49, the parabola hits the x-axis at exactly 1 point. When k equals 48, the parabola hits the x-axis at 2 points. When k equals 50, the parabola does not hit the x-axis at all. Therefore, there are no solutions, which is what we want. 50 is your answer. Way number 3, use the discriminant. The discriminant b squared minus 4ac is negative when there are no solutions. Set the discriminant up as less than 0 and solve for the unknown b term. First, I got the original equation in standard form so I could identify a, b, and c terms. Then I plugged into the formula. I get negative 56 squared minus 4 times k times 16 is less than 0. That gives us 3,136 minus 64k is less than 0. Plus 64k on the left side, plus 64k on the right side leaves us with 3,136 is less than 64k. Divide by 64 on each side to get 49 is less than k. In other words, k is greater than 49. The first integer greater than 49 is 50, so that's our answer.